walk you through, some things that I think are important when it comes to logarithms. You can tell me what you do or don't remember. So there's log base b of x, and then there's natural log of x. You're probably graphing mostly this type, is my guess.
Oh wait, sorry, it's not logarithmics. It's like it's actually sine and cosine.
Okay, good to know, because they're very different. All right.
Yeah.
Yeah. Okay. Yeah. This is a popular lesson I get: sine and cosine. Okay. So what you have to know as a student is the parent function for each of these. Okay. And with sine, it starts at the origin, and then there are 4 other places. So it goes up, it comes back down, goes down a little bit further, and then comes back up. You have to know these 5 points, and you have to be able to make this nice smooth curve. You probably saw that in class today or this week. And then cosine is slightly different. It starts high. So it starts up here, drops down, comes to a minimum, comes back up, and repeats here. And you want to get good at these kind of smooth lines that connect together like that. But these have to be well known to you. All right, now, do you prefer tables, or do you think you can manipulate the graphs?
I think he's teaching us how to manipulate the graph.
Okay, we can give that a try. If you don't like it, we can also try tables. Okay. So there are a couple of things that the teacher will do, and kind of that like example number 1. So the first thing they always try to have you learn is how the period affects the graph. Do you understand what I mean by period?
Yeah. So
Okay.
like the space in between the what do you call them?
So the way that I like remembering this is it's the distance horizontally until the graph repeats. And I mean, it's kind of wordy, so it'll make more sense when we do an example. So let's say I ask you to do the sine of 1/2 x. We're going to graph the sine of 1/2 x. Now the period has a formula. It's 2 pi over b. B is the number in front of x. Now your book might use a different letter. Your teacher might use a different letter. I have no idea. You have to think of it as the number in front of x. Whatever's in front of x, that's b. Do you remember what you guys used in class? If you're not sure, I'll just keep going.
Use anything specifically.
Okay. So the reason I'm doing it this way is it will work for everything we're going to do from here on out with graphing, not just for like this quiz, but for other quizzes you'll have. So for you, your period is 2 pi over 1/2, which is 4 pi. Is that okay?
Yeah.
All right. So if we were to go back, and we're going to do this every time, we're going to graph the parent function. So you want to get really good at doing this, graphing those 5 points. Okay. What the period does is it stretches it out. Now normally this is 2 pi. Okay, like if we go back up to our parent function here, the period for both is 2 pi. And what that means is that's how long it takes for it to repeat. So you might say, well, what about this point right here, Matthew? Isn't it repeating there? It was coming down. Notice how it's coming back up. That's why it repeats, because if we go left here, the graph is coming up at the origin, dips down and comes back up. That's what I mean by repeats, like it comes back onto itself. So in your problem here, the period is not 2 pi, it's 4 pi. It's like, well, what does that mean? Well, what it really means, and I'm gonna have to do a better job of drawing this. Let's assume for a moment that this is really 2 pi. that means that if I go out in another 4 squares, this is 4 pi. That's drawn really poorly, sorry. Okay, 4 pi. Now you have to make some cuts. You have to make some cuts for the midpoint. I've already got one. You always make a cut for the midpoint, 2 pi, and then you cut between the 0 and the 2 pi. So that would be at 1 pi. And then you need another cut right in the middle between 2 pi and 4 pi. So this one's pretty straightforward because you can just count 1, 2, 3, 4 pi like that. Okay. And then because of the sequencing here, you always start at the origin. And then at this first point, you're going up. Like, let me try to make it clear that this first point is really that one that we started with. It's really now here. The second one comes back down, hits in the middle. Okay, so that's the second point. The third one is here. See that there. And then the last one comes up like that. So a lot of lines. I'll try and clean it up here, but you can see it's got the same shape. It's just sort of, you could use the word like pulled or stretched horizontally.
So if it's a fraction, does it always stretch?
Yes.
Okay.
But in full disclosure, like the way I will tell you to graph these things is they're all going to kind of look the same. They only look stretched when you have the parent function there to compare it to. So what I mean by that is, let's just say you graphed it so that this was 4 pi, this is 2 pi, and this is 1 pi, and this is 3 pi. It looks exactly the same as the parent function because your graph is sort of squished in, so to speak, if you're comparing it to the first one. So this is the real challenge for me, is like, we don't know how your instructor is going to grade you on this part of the course. So some instructors, they just give you something like this on the right, and they say you label it. Some of them give you tick marks, and they say that is always pi right there. They just say that is pi, and you have to figure out everything in between. Do you remember from class in your notes, like how the instructor was labeling the graphs?
He labels them differently. Like sometimes it's 6 pi, sometimes it's 2 pi, sometimes it's 3 pi over 2. It just depends on like the way the graph looks.
Yeah. So, okay. So I think he's doing kind of the way that I'm talking about down here, which is like, doesn't matter what the period is. We're always going to go out and make a cut on this line. That's the full period. And then we're going to back off and find the midpoint, and then the other midpoint, and then the other midpoint. Any questions on this so far?
No, I'm good.
Okay. And if this feels slow, I'm trying to really incrementally get into this because I don't want you to, really have issues here, because this is really a tough subject. So let's say I want you to graph cosine pi over 4x. So the period for cosine is 2 pi over b. B is that number in front of x. So it's 2 pi over 4, which when you simplify becomes 2 pi times 4 over pi. The pi's cancel and you get 8. So here's what that means. It means that you got to go out 8 from the origin. So like, that's where like you could Jane be like, well, that's 8, because you feel like that's 8. Like, that's totally fine. Because we have grids, it's nice to go out, like count them nicely, 1, 2, 3, 4, 5, 6, 7, 8. That's kind of what your instructor was. That's what I think your instructor meant. Like he could have started right here in the middle and said that's 8, because he's got just a whiteboard with no grid on it. Does that sound right to you?
Yeah.
Okay.
And you just divide it into 4.
Yeah. So you go midpoint, the other midpoint, and then the other midpoint. Now cosine starts high, which means that It's going to start up here. I haven't been labeling this, but it starts at 1. The first cut, it goes down. The second cut, it comes to a minimum. Then it comes back up like this. Let me know when I can move on to another example.
Okay.
You ready?
Yeah.
Got it. Okay. So now we're going to introduce a couple more things. We're going to introduce amplitude. So let's say it's 2 sine 4x. Okay. So in this problem, the period is 2 pi over b. B is 4. So it's pi over 2. Okay. The amplitude, and this will only matter in kind of more complicated problems, but it's the absolute value of that leading coefficient, which is 2. It's 2 because it's the absolute value of 2. It's not 2 because it's the number in front. Small difference, but it will matter later on. Okay. So this is where if you're so I guess we're not to beat over and over again. Like if you're the kind of student that wants to put pi over 2 right there, you're gonna have a problem because you got to squeeze in 4 points in this. And I think you're writing large-ish. I don't recall, but I don't recommend that. So what I would do, and I'm gonna not use the grid space this time just to kind of really emphasize this. I'm just gonna say that's right there is pi over 2 arbitrarily. And then I got to cut it in half. That's pi over 4. I know that one. If you're not sure how to find the next one, which may be the point here, there's a couple of ways. You're literally finding the average between 0 and pi over 4. So the average is you add them up and you divide by 2. 0 plus pi over 4 divided by 2, which ends up being pi over 8. Alternatively, you can multiply pi over 4 times 1/2. The average method, though, is better. It is really preferred. So to find the one between pi over 4 and pi over 2, you would add them up. Yes, you have different denominators, but you should be able to handle this. At least that's what your instructors think to themselves when they're teaching this part of the course. So you get 3 pi over 4 over 2, 3 pi over 8, like that. So if I'm grading you on labeling these correctly. I don't know what your instructor will be grading you on, but that's at their discretion. Now, just as an aside here, it's pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. Do you see how they step up by the same amount each time?
Yeah.
And that should be the case. These are just the simplified versions. I actually think it's easier to do it down here on the bottom because you're just counting, but your instructor may say you need to simplify. That's all that's going on above there. Now I'm going to first graph the parent function. So that's where you start at 1 and -1. So sine starts at the origin, sweeps up, comes back down, reaches a min, and then comes back up. So this is your parent function here. Do you recall from the class now what the amplitude does? How does it stretch the graph? Do you remember?
Doesn't it just move it up?
It pulls the points up. Now, it does not pull
Yeah.
the 0 point up, but it pulls that one up to 2. You're literally multiplying the y value by 2. The 0 stays the same. That last one pulls down to -2. And like this. So you can see it. That's why I switch colors here. Like that. I think it's good to show the transformations, not just wait till the end. You might get partial credit if you're off on something. If you have different colored pencils, I would use that. If you are using pencil though, just like a single pencil, try to do it real light, and you can even erase at the end, something like that. Any questions on that one?
No, it's pretty straightforward.
Yeah. So let's do one more here. Let's go y equals -3 cosine, and we'll go 8x this time. right? So again, like if there's a recipe here, it's the first thing you do is you deal with the period. You're like, what's my period? It's 2 pi over 8, which is pi over 4, which isn't good, but that's what it is. The amplitude this time is the absolute value -3, which is 3. Okay. And then I always recommend starting by graphing the parent function. All right, so pi over 4, I'm gonna 1, 2, 3, 4, 5, 6, 7, 8. I'm gonna go out far enough where we can see this. That's pi over 4. This is pi over 8. Can you tell me these other two cuts, please?
Okay, hang on. Let me just write this down.
Yeah, sorry, I know I'm going fast. Please take a moment, get caught up.
So half of pi over 8 would be pi over 16.
That's right.
And then would that be pi over, wait. Sorry, how would I calculate that again?
So there's two approaches. The first way is to just find the average of pi over 4 and pi over 8 and pi over 4. That's what most students do, and I think that's a good way to do it. The alternative way is to realize that it increments by the same amount. So this is 2 pi over 16, 3 pi over 16, and then 4 pi over 16. And you can see that 4 pi over 16 reduces to pi over 4, 2 pi over 16 reduces to pi over 8. So this missing one is the 3 pi over 16. So if you were to add these up on the right, you would get the same thing, 2 pi over 8 over 2, which is 3 pi over 8 over 2, which is 3 pi over 16. All right, so just sometimes these get in the way when graphing. I'm gonna have to move these around a little bit. So and I'll write this down. Always graph the parent function after you do the period. Like, don't try to do too much. It's an easy way to make mistakes. This is 1. This is -1. So it starts high, goes low, comes up, comes up, and make them kind of smooth. Some instructors are really picky on how you make these things look, and that wasn't my best effort. But point is like, don't draw straight lines because they're not straight lines. So this -3 here, it actually does two things. It pulls, and then it flips. And the order does not matter, but you want to make sure that you don't mix them. So you got to choose. Like I would tell you, okay, like pull it first. So now it's down here at -3 and +3. So there's the pulled one. Whoa. And then the negative is the flip. Change the color on that. So that moves everything over the x-axis, but the ones on the x-axis, they stay the same. And you can see that it has this new shape like that.
So it just inverts it.
Yes, the negative, if you recall, like a quadratic, like remember y equals x squared opens up, y equals -x squared opens down. That's what the negative does. It flips it over the x-axis. So the colors really help. I know it's not what we do normally when we take notes, but if you go to if and when you go to college, you'll find people do a lot of note-taking stuff to really make this clear in the classroom.
Yeah, I think he wants to do that. He wants us to do that in the test. He wants the before and after.
Yeah. So like what I've seen from some instructors is they give you like 3 graphs depending on how, if you've got three things that are changing it. If you don't get 3 graphs, just stage it out. Let me know when you get all this down. I'm gonna do, of course, want to do a lot more examples with you on this. This is hard to do the first time.
All right, I'm good.
All
Ready?
right. So here's what you might see on a test, and I'll ask you if you've seen this language. It'll say something like graph the following, sine, cosine, whatever it is, in 2 full periods. Have you seen that?
No, I haven't.
Okay. So this is where we got to be really careful here because what I mean by 2 full periods, before I give you another example, is sine looks like this. That's 1 period. But it repeats, like we're talking about that all, bunch here, it repeats, meaning like it looks exactly the same in that 2nd period. But it repeats both forward and backwards. So I don't know if you have time, I don't know if your instructor answers email over the weekend, but you might want to ask a question like, will we be asked to graph more than 1 full period, meaning 2? And then will we be asked to graph them in the negative direction? Because that's where it's not harder, but it just creates more confusion because it's replicating the same thing but going left and going right. So if you want those words, I think they're worth putting in this this lesson here today. Will we be asked to graph more than 1 period? Question mark. Will we be asked to graph in the negative direction? And you're doing all this not just so that you know in advance. So you're not surprised when you get there. Like, I have no idea how to do this. All right, let's move to another example here. Let's go back to sine. So let's say it's y equals 2 sine pi over 8 x plus 1. So we're introducing something new here. You still want to first determine the period. I'd like you to calculate the period for us, please.
Would the period be 1/4?
So it's 2 pi over 8. So we've got to just remind ourselves how to deal when you're dividing a fraction. It's the same as multiplying by the reciprocal. Can you tell me what this simplifies to?
Oh, it'd be 16.
16. Good. Okay. So here's kind of your thought process on period. If the number in front is a fraction, generally it's a whole number. If the number in front is a whole number or something, whole number and then pi, then it's a fraction, your period. It's I was seeing something on social media. It's like sometimes you got to do the opposite to get what you want in life. All right. So period helps you determine where to start your graph. And I'm not going to go out 16. I'm just going to call that 16 there. Just arbitrarily. So we need the 2 midpoints, 8 and then 4. And then the other one, 12. So it's real nice when you get whole numbers there. All right, so the next thing is the amplitude. What is the amplitude of this graph?
It'd just be 2.
Be 2. So I always recommend graphing the parent function. Now you can graph the parent function with the amplitude if you want. It doesn't matter to me. Whenever you're flipping, I usually wait to flip it. But that's kind of your call here. So I will graph the parent function again, like I've been doing. and then I will do, deal with them one at a time. So the next thing I'll deal with is the amplitude of 2. So that just pulls up any points or pulls down any points. Like this. And then something new, something we have not talked about here, is this +1. Do you remember from class what that is?
That just moves it up. Or
Yeah,
I don't know how to explain it, but the whole graph gets moved up one.
exactly. So vertical shift is what we would call it. You could say up 1. Very important to wait till the end. And it has to be done after the other stuff. That's why I didn't even show you it until. So you literally move every point up 1. Something like that. Now, if, for example, your instructor said you must graph 2 full periods, let's just say that was in your instructions, graph 2 full periods. Your preference is to always go to the right. Don't go negative unless they ask you to. Going right's much easier than going left when you're graphing. You still need to label your axis again. So you just create a few more cuts. You're like, all right, that's, what am I going up by? That's 20, that's 24, that's 28, that's 32. And if you can just, it depends how accurate you have to be, but you can see the shape in blue. You can either follow it or you can say, all right, I guess I got to go up, then I'm coming back down, then I'm going back down, and then I'm coming back up. But you're just making the same 5 dots now to the right.
Okay, got it.
So notice everything we've been doing really is centered on this like 1 period. Like you got to get that 1 period down perfectly. You have to be able to do this, A+, gold star, all that. It just has to be perfect. And then the rest of it's just an extension of that. So let's look at another example here. You'll notice I'm switching between sine and cosine. There are other graphs. Have you done tangent? Have you done cotangent?
No, we're only doing sine and cosine so
Thank
far.
goodness. Thank goodness. Yeah, and you will reuse sine and cosine with other graphs, and you will reuse them again in calculus. Just you got to get this stuff down. So let's look at a new one here. Let's say it's minus cosine x minus 2. Okay, and if you're ever unsure where the parentheses are, you can always ask. Like if they're not there, it's just the x. I'm doing this for emphasis to make sure you see that it's just the x is inside. So this time, the first thing we're gonna do is calculate the period, just like all the other problems. So it's 2 pi over b. What is the b? What is the number in front of x that's inside parentheses that's not written?
Just be 1, so the period would be 2 pi.
2 pi. We like that. We're like, yay. Got something nice. Now it's good if you can look ahead a little bit to kind of say, well, what's happening here? This thing out in front, this negative, do you recall what it does? Trying to get to where I can get a different color. This negative out in front, do you remember what that is?
It flips the x, or flips the graph over the x-axis.
Yeah, it flips over the x-axis. And then how about this minus 2 over here to the right?
It would move the graph down, or move all the points down by 2.
Down 2 units. I think, well, I always mention this to students when we're doing quadratics, and like the order matters, and nobody like really wants to buy into that, but the order really matters here. Like you need to flip and then go down. You don't go down and then flip. There are scenarios where it will not work, which is why the order matters. Now, this problem might ask you to determine the amplitude. Can you tell me that, please?
It'd be just 1.
Good. Okay, so we're gonna go out 2 pi, and I'll just do it there. That's 2 pi. So because it's cosine, it normally starts high, goes low, comes down to a minimum, comes back up, comes back up. So that's your parent function here. We can label some of these other points. Pi, you can label them on the other side of the axis. It's up to you. You do need to label the vertical axis as well. I'm not very good at that. I would probably get dinged on the grade for that. So the flip, you literally just flip every point. Like that. And then every point goes down 2. So every point goes down 2. Every point goes down 2. What is going on? I've misgraphed this. Okay, that point goes down 2. That's that one. Confusing myself. That one. That one. Okay. There it is. And if you were asked to go out another period, you would want to add your labels on the x-axis. This is where it's like, what is that? You know, if it's 5 pi over 2. So the more you do it, the faster you get at these things, obviously. But you just repeat the same graph. It has to look exactly the same in this next little window. Oops, sorry. All kinds of technical problems today. There we go. All right. You ready to try one on your own?
Yeah.
Okay. Let's go y equals -4 sine 1/4 x, like that. And please ask me questions as you go, if you have any. I'm going to graph this in another window and snip it in.
The period would be so 1/4 8 pi.
Yes.
Huh. And the amplitude would be 4.
That's correct.
This graph will also flip over the x-axis.
Yes.
So the points would be 2 pi, 4 pi, 6 pi, and then 8 pi.
Yeah, have you graphed, have you made the graph yet? I'll snip it in whenever you're all done.
I'm almost there.
Okay,
I'm working with
okay.
Flash
Yeah,
right now.
take your time. I want you to get the direction correct, all the points labeled.
Okay, I have my graph.
Excellent. All right, I'm going to snip in the Desmos. So if you do some practice on your own, I would encourage you to graph using Desmos. I'll also snip in the actual graph so you can see it, or I'm sorry, the equation. But what your instructor is grading, they're grading you on, do you have these 5 points? Like that's what they want to see and the connection between them. So notice what I did here is I stopped the graph at the end of the period. It goes on forever. Sometimes it can be too much to look at. Does your graph look somewhat like this?
Yeah, it does.
Perfect. Okay. So what I'd like to do with the rest of the time is talk about phase shift. Any idea what I mean by that? Did you talk about that in class?
I think we did, but I need a reminder.
Of course, yeah. This is the hardest, most difficult. 10 minutes probably isn't enough, but we will get into as much as we can. So it's kind of like when we were doing rational functions, like sometimes you just like you start out by like, okay, figure out the vertical asymptote, and then later on you learn that they're holes. That's kind of what's going on here. You actually start with the phase shift before the period. All right. Now we're going to do something really straightforward here. Let's say it's cosine x minus pi. Okay. So the phase shift in this problem is pi right. Pi right. Now the reason it's pi is because it's this thing to the right of cosine. There's a little bit more to it than that, but let's keep it simple for now. It really does depend on the number in front of x, but since it's 1, we can go with that. Does this look something like you might have seen in class, or were you get even more difficult ones than this?
No, I've seen something like this.
Okay. So your phase shift, and I use PS for phase shift pi right. So when you graph, you're used to starting at the origin. Not going to happen now. You start at the phase shift. This is very important. You go out 1 period from the phase shift. So you have to figure out the period 2 as well right away. So your period in this problem is 2 pi over the number in front of x, which is 1. So you go out from pi plus 2 pi, which is 3 pi. So you create your window starting at your phase shift, and then you go out 1 period. And you treat this phase shift as like your new starting point of your graph. Does this sound familiar to what you've seen in class?
Yeah, it does.
Okay, great. You still find the midpoint, 2 pi. You still find the next midpoint and the next midpoint. Okay. You still do that. It's the average method is good because that sequencing of like counting up, it still works. You just have to start it at the right number. All right. So there we go. We got, okay, it's 1 and minus 1. So that's cosine starts high, goes low, reaches a minimum, comes back up, something like that. All right, you ready for a slightly more difficult one?
Yeah.
All right, so let's say it's y equals minus sine x minus 3 pi over 2. What is the phase shift for this one?
So it'd be three pi over two, right? Or
Right,
three
yeah.
pi over two, right? Yeah.
Yeah, and that really does matter. We'll get into that. We'll do the left ones here shortly, but they get just harder. Anytime you're going left, just gets harder. So, we gotta make a graph. Sorry, lost track of what we're doing. We're gonna make a graph here. And I'll just arbitrarily choose, like, to me, it doesn't matter. Like, I would just go right there, but that's obviously not to scale. I don't know what to tell you. You can you can play with that. If you really want to go at 3 pi over 2, you can. Do not get hung up on the scale though. So now we got to go at 1 period. So your period in this problem is 2 pi over 1. So we're keeping the period nice because we're not trying to overdo it on these problems, but you got to maybe come off to the side and be like, what's 3 pi over 2 plus 2 pi? So you got to be able to add unlike fractions. So this is really 4 pi over 2, 3 pi over 2. So that's 7 pi over 2. That's 7 pi over 2. The one in the middle is 5 pi over 2. And then the other ones are 4 pi over 2, which is 2 pi, 6 pi over 2, which is 3 pi. Sometimes it's good to alternate where you label them. So you're just moving. With the phase shift, you're just moving where it starts. All right, it starts there. Sine still goes up, comes down, goes down, and comes back up. And then after you've dealt with the period and the phase shift, you have to do the phase shift and the period first. Do not wait to do those. Then you can start handling the other stuff like the reflections. Very important to wait on those.
Okay, got it.
Now this is where I don't, there's two directions we can go. We don't have enough time to cover everything. We can either do phase shifts left, or we can talk about more complicated period changes with phase shift. Do you have any examples from class to kind of help me guide you on that? You can just,
We're not going to the left, so probably more complicated phase shifts.
okay. So let's go y equals cosine pi over 2x minus pi. Let me just see if this works. Should work. Okay. This might be too complicated. Let me just make this pi out in front. Okay, for our first example. All right, so whenever there's a number in front of x that isn't a 1, you need to factor out the number in front of x. So in this case, it's pi x minus 1, like that. Is that okay?
Yeah.
Sorry, let me graph this one real quick just to make sure I'm giving a good example. Yeah, okay. So this time, the phase shift, sorry, I'm losing track of myself. Yeah, sorry. I never do these by hand, by the way. And the reason you're learning this, I'll just add this in here, I think this is important, is you always graph data when you get it. Like if someone gives you a data set, always the first thing you do is you graph it. You're like, oh, it looks like a cosine, or it looks like a sine or something. Like that's really important. So your recognition of these is why you're doing that. But in this problem, your phase shift is 1 right. Okay. It's 1 right because when you factor out the pi, that's what's left over. So when
Yeah.
in the previous problem, like there was a 1 there. So if you factor it out, you still got 3 pi over 2. It's whatever's inside parentheses so long as you factored out whatever's in front. The period is what changes, because it's still 2 pi over b, or the number in front of x, which this case is pi. So your graph means you're starting at 1 and you're going right 2. So I'm gonna just call that 3, just to give us enough space when we're seeing this. But very important, you start at the phase shift, go out 1 period, find the midpoint, find the other midpoints if you need to. And then with cosine, it starts high, comes low, comes low, comes up like that, stuff like that. And I can add all the other stuff, like I can add an amplitude out in front. I can add a negative. I can add a vertical shift over here. I generally, what they do, Jadon, is they like give you like amplitude and phase shift, and then they give you like period and vertical shift. Like they don't give them all together, but some instructors do give you like that final question where they're all together, where you got to know how to do all 4 of them, all 4 of the shifts. That's something to look in your notes and try to like pattern, like that's what I did today. If I could just review, since we don't have a ton of time with this, is you notice I start with just a period change, then I went period and amplitude. Okay, then I went period, amplitude, and a shift. But I never did a phase shift. I waited till the end to do a phase shift. So when you're looking over your notes, keep that in mind, because the phase shifts are the most difficult. So they're not going to give you a lot of other stuff to be messing with, because it does get more complicated. All right, well, that is it for us for today, Jadon. I am doing an SAT prep course starting next week. If you're interested, I can get you enrolled in that. First lesson's free next Saturday. Or if you know someone that would be interested, that would be appreciated. But that is it for us for today. Good job. I will see you next time.
Yeah, you too.
Have a great
I'll
rest of
see
your
ya.
day. Okay, bye now.
Thanks. Bye.